Good morning, grade 7 students. In this video, we're going to start our new idea talking about the respiratory gaseous exchange. So let's start gas exchange in the aquatic medium. Aquatic medium, gas exchange in the aquatic medium, we have this experimental procedure. So experimental procedure, it represents the steps of the experiment. So first of all, what do? We place a goldfish in a water enclosure, then we put the oxygen probe. This is the goldfish. It's named the goldfish because it has a gold color. That's why it's called the goldfish. And we place it in this water enclosure. We connect it to the oxygen crop that is connected to the measuring apparatus. This measuring apparatus is the oximeter, and it's a digital one. Oximeter, the function of this oximeter is to connect to measure the amount of oxygen gas. So they are used to measure the oxygen gas. Also, we have a control measurement without fish that should be done. So here we have two experiments, one with a fish and the second one without a fish. So this one without a fish is considered as the control experiment. And this is used to compare and to explain the results. So here the level at the beginning of the experiment, it was 9.2 milligram per liter. So at the beginning of the experiment, the quantity of oxygen gas, it was 9.2 milligram per liter. So here we draw the results of this experiment in a graph. This graph is shown in document B. But before we move to document B, I wanted to talk about these notes. Note number one, the control tube is used to compare and to explain the different experimental results. So here the control tube or the control experiment, they have the same meaning. The control is the one without the fish. Why do we use it? It's used to compare and explain the experimental results, the results of the experiment. And second, we have the role of the oximeter. Why do we use the oximeter? The oximeter is used to measure the amount of oxygen gas. So here there are two important notes. You have to keep them in your mind that we have to do them. First, you have to know that the control tube is used to compare and explain the experimental results. Number two, that the oximeter is used to measure the amount of oxygen gas. Here we move to the results of the two experiments, with and without the fish. So this one, the control is without fish, while the second one is with the fish. The second line is the line with the fish experiment with the goldfish. Here are the numbers that show the quantity of oxygen in milligram per liter. Here are the values 9.600, so you can simply write it as 9.6. Here you can simply write it as 9.4. Here simply you can write it as measured in the oximeter is 9.2. Here we have 9, and here we have 8.8, and here down we have 8.6. Down on this axis we have the time. So they move here, and the end we have 5. So it's the time in minutes. Okay? And here we move 30 seconds. 30 seconds, 1 minute, 1 minute, 30 seconds, 2 minutes, 2 minutes, 30 seconds, 3 minutes, 3 minutes, 30 seconds, 4 minutes, and 30 seconds, 5 minutes, which is the end of the experiment. So if I ask you, first question for the first bonus point, what is the title of this graph? Who can give me the title for this graph? Yes, Lamar, the first one to raise her hand.
A graph showing the quantity of oxygen and
The
and
quantity, first, before you continue, Lamar, graph showing
yes,
the quantity, or we have a word before the quantity? The variation.
variation
Excellent. So the variation of the quantity of oxygen, yes,
in milligram or
per liter.
liter.
This is milligram, and this dash is called per liter. Okay?
Yes.
Yes.
And the control.
No, no, no. I want the title of the graph. Can you give me the title only? I need only the title of the graph. Do you have an answer, Lamar? Okay, let's have another one. Thank you, Lamar. Very good. So you get 50% of the answer. Thank you. Very good. Moving to Ali Nasiruddin. Ali, what do you think? What is the title of this graph? Ali Nasiruddin, yes, you can speak.
Yes,
Yes. What is the title of this graph?
it's a graph showing the variation of quantity of oxygen in milligram per liter
Yes.
as a function
Of what?
time in minutes.
Very good. Excellent, Ali. Thank you. So this is a graph showing the variation of the quantity of oxygen gas in milligram per liter as a function of time in minutes. So let's move to the first line, which is for the control experiment. So I'm going to clear this and then we can start. So the first line, the one with the control, meaning that with no fish. Who can analyze this for the control only? Who can give me the analysis for the control experiment only? Let's see by raising your hands. Who can give me the analysis for the first? Who can analyze only the line or the graph for the control experiment? Shall I choose? I'm going to choose. Let's move for Adam. Adam Hashashi. Good morning, Adam.
Good morning.
Okay, can you do the analysis for the control experiment?
Yes.
Yes.
Time zero.
Excellent.
Uh,
The quantity of,
the quantity of oxygen gas
it was what?
in
It
the
was
control.
9.2.
It was 9.2.
Unit. What is
As
the unit?
time decreases.
No, no.
Uh,
Pay attention, yeah, Adam. You have to mention the unit. So quantity, you said at time zero, the quantity of oxygen was 9.2. What is the unit? Milligram
uh, milligram liter
per liter.
liter
Okay,
per
so then as time increases from
as
0
time as time increases from zero
to
to
5
uh,
minutes,
5 minutes.
what happens?
Uh, the amount of oxygen gas
Yes,
remains the same.
remains constant. Okay?
Yes.
Remains constant. So here,
Okay.
Adam, can you repeat it? Yeah, repeat it. All of you pay
At,
attention, please.
at time zero, the
Yes,
amount of oxygen gas was 9.2 milligram uh,
per
per liter.
liter. Okay, excellent.
As time increases from zero till 5 minutes,
Very good.
the amount of oxygen gas
Yes,
remains constant.
excellent. Remains constant at 9.2. Very good. Very good, Adam. Thank you, Habibi. Thank you. Moving now for the second experiment. Who's going
عارف؟
to explain the second one? Please, second experiment with the goldfish. Adam, please mute yourself.
أنا
Okay. Yes. So, moving for the second experiment, I'm going to choose for this one new voices. So I move to Adam Arhauni. Adam, good morning.
Yes.
So, can you analyze the second experiment with the goldfish, Adam?
Um.
At time zero. Yes, Adam. Start at time zero.
At time zero.
Yes.
Um.
What was the quantity of the oxygen gas? Here is the time zero. Here.
9.2
Milligram per liter.
milligram per meter
Per liter. Not meter. Liter.
per liter.
It's volume. Yes.
Yes.
Okay. As time increases from 0 to 5 minutes, what happened? What happened for the oxygen gas? It remains constant at the case of the control, or it increases or it decreases?
It decreases.
Okay, you have to tell me. Yalla, go.
As time moves from 0 to
Increases.
5
No, no,
minutes.
no, no, no. Stop, 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 stop. You don't have to say moves. You have to mention
Oh,
increases. Okay? Not moves. As time
as time
increases. Yes.
as time increases from 0 to 5 minutes,
Very good.
the
Excellent.
amount of oxygen gas
Yes.
um
Increases or decreases?
decreases.
To what? To which value? Here is the value to 8 point
8.8
milligram per liter.
liter.
Okay, thank you. Thank you, Adam. So I'm going to make a quick revision about what we have explained with Adam Hashishi and with Adam Arauni, two Adams. So here, in the control experiment, at time 0, the quantity of oxygen was 9.2 milligram per liter. As time increases from 0 to 5 minutes, the quantity of oxygen it remains constant at 9.2 milligram per liter. Whereas in the in the experiment with the goldfish, where we have the fish, the quantity of oxygen at time 0 it was 9.2 milligram per liter. But as time increases from 0 to 5 minutes, what happened for the quantity of oxygen? It decreases from 9.2 down to 8.8. So when we have the fish, the quantity of oxygen decreases. When we don't have fish, the quantity it remains the same. What can you deduce here? I want the conclusion. Who can give me the conclusion here? When we have fish, the quantity of oxygen decreases. When we don't have fish, the quantity remains the same. So what is the function of the fish? What does the fish do here? Yes, Sari. Sari Shab.
Yes,
So what do you conclude here?
we conclude that the
Whenever we have the fish, the amount of oxygen is decreasing. So what can
yeah
you conclude?
when we have the fish, the oxygen
Yes, what does the fish do to the oxygen?
it makes it decrease.
Okay, so what does it do for this? You have a word, two words. You can use one of them. Hassan Isrur,
Ustaz, can I answer?
please, no one answer without raising your hand and without giving him the permission, please.
Yes,
Okay, Hassan Isrur, yes, what do you think about this?
we can conclude that the fish is taking in oxygen.
So you have to use another word than that taking in. Can you give me another word that taking in?
Uh,
You have many words, and we use mostly two words for taking in. It's correct, but in biology we have used these terms. Taking in. What do we mean by taking in? Means
inhale.
inhales
Consuming.
oxygen or it's consuming. Please, no one answer without the permission. Okay, Hassan? It consumes
Yes.
or it absorbs the oxygen gas. So you use both terms. You can use any one of these. Okay?
Okay.
Okay, thank you, Hassan, and thank you, Sari. So let's move here. So formulate the tested hypothesis in the experiment of document A. So what is the tested hypothesis here? We have oxygen and we are measuring the oxygen for the fish. So what is the hypothesis here? Hypothesis, I have to be logic. I have to predict in a logical way. So what do you think? Maybe the fish will absorb the oxygen. Maybe the fish will consume the oxygen. Maybe the fish will inhale the oxygen. All of them, they are logical. But it's not logical to say maybe the fish will release the oxygen. It's not logical. So logical, the fish will absorb the oxygen. So maybe the fish absorb oxygen. This is the hypothesis. It's logical, and you have to write the word hypothesis before we start. Maybe, and you have to write it as one sentence without saying maybe the fish will absorb oxygen because the amount of oxygen will decrease. This is not a hypothesis. Hypothesis includes no justification. It's only a sentence. Okay, moving to second part. They said pick out the concentration of oxygen indicated by the oximeter at the beginning and at the end of the experiment. It's very easy to pick out. Pick out, either you have to bring them from the document or figure or a graph, or you have to pick out from the text. Here we have the graph. So at the beginning, in both the control experiment without the fish and that with the fish, the quantity of oxygen, it was what? 9.2 milligram per liter. After 5 minutes, the concentration, which is after 5 minutes, the end of the experiment, the concentration becomes 8.8 with the fish, and it remains 9.2 without the fish. Okay, let's continue here. So lime water test. Please, anyone who unmuted yourself, mute yourself, please. So lime water test. Lime water test is in a fun and an easy way to test the presence of carbon dioxide. What is the formula of carbon dioxide? CO2. So carbon dioxide will produce a precipitate. This precipitate will be at the bottom of the tube. This will turn the lime water to become a turbid one or becomes a milky one. So here we have lime water. Lime water, it's clear. What the meaning of clear? It's like the water, the normal water. It's clear, it's transparent. Whenever it binds with CO2, whenever we have CO2, this lime water, it becomes turbid. So we have another word for turbid. We can say it becomes milky, or we can say it becomes cloudy. All of them, they have the same meaning. So if I want to test the presence of carbon dioxide, simply what do? I bring the lime water and I test it. I lime water and I see if this lime water becomes turbid or becomes cloudy or milky, this means that we have carbon dioxide. While if this water remains clear, this means that there is no carbon dioxide. Let's move to this experiment that is related to the fish. Lime water test. Lime water is colorless. What the meaning of colorless is clear in the beaker A, while in beaker B it becomes turbid or cloudy or milky. All of them, they have the same meaning. Cloudy, turbid, milky, all of them, they have the same meaning. Now pay attention to this figure. In beaker A, we get the water from the enclosure without the fish, meaning that from the control experiment. We bring the lime water without the fish. So here the lime water is clear. While when we bring the lime water from the enclosure with the fish, where the fish exists, the lime water, it becomes turbid, or you can say it becomes milky, or you can say it becomes cloudy. So what can you deduce here? In tube A, do we have carbon dioxide? And in tube B, do we have carbon dioxide or not? Raising your hands to answer this question. Yeah, go. Raising your hands. Hassan Surur the next time. So I want new voices. Yes, Jude Abdurrida. Jude, what do you think? In tube A,
Yes,
lime
Ustaz.
water. Tube A, Jude, the lime water is clear. So what do you think?
Okay.
Do we have carbon dioxide?
No.
No, so there is no carbon dioxide. There is no CO2, no carbon dioxide. While in the second one, Jude, it becomes turbid. So what does this mean?
There is carbon. There is CO2.
We have CO2. Very good. So if you look here, the water is clear, while in this one, it's turbid. Thank you, Jude. Thank you very much. So here Jude says, in tube A, the lime water is clear, so there is no CO2, while in tube B, it's turbid, so we have CO2. So here, what can you conclude? Without fish, we don't have CO2. The lime water, it stays clear. While in tube B, where we have the fish, the lime water, it becomes turbid. So what do you think, Adnan Arauni? What do you think about this?
Yes, it does.
Yes, what do you think? When we have the fish, the lime water becomes turbid, so we have CO2. While when we don't have fish, the lime water stays clear, so we don't have CO2. So what can you conclude here? Can you give me a conclusion? From
Yes.
where did the CO2 come?
From the fish.
From the fish. So the fish inhales or exhales the CO2?
Exhale.
So it releases the CO2. Very good. Thank you, Adnan. So a fish releases the CO2 in the water, and this will change the lime water from being clear to being turbid. So the CO2, it comes from where? From the fish. So they say compare the aspect or the appearance of the lime water. What the meaning of the appearance? How did the lime water appear in document C? So appearance of lime water in document C, it is clear or it's colorless in A, in beaker A, where the water comes from the enclosure without the fish. So here we don't have fish. So there is no release of CO2. While the appearance of lime water is cloudy, or you can say it's turbid, or you can say it's milky in what? In B, where the enclosure, where the water, sorry, it comes from the enclosure with the fish. So when it comes with the fish, meaning that the fish releases CO2. This is the conclusion. The fish releases CO2, and this CO2 will make the lime water turbid. So here we can conclude that in order to test the presence of carbon dioxide, what do we have to do? First, we have to bring the lime water. Lime water test is done to identify the presence of CO2. So as a conclusion, let's write it here, lime water test. So the lime water test is done to identify the presence of CO2. Lime water test. If we have CO2, what will happen? One, first result. If there is CO2, if there is CO2, what will happen? Yeah, raising your hand. If there is CO2, what will be for the lime water? It becomes what? I wanna new voices. I wanna hear Michael. Good morning, Michael. Michael Hussaini.
Yes.
If there is CO2, what will be the lime water? What is the result for the lime water? It becomes what?
Turbid.
Turbid. Lime water becomes turbid. Or you can say lime water becomes turbid or becomes milky or becomes cloudy. All of them, they have the same meaning. So lime water becomes turbid. Very good. Thank you, Michael. The second one, if there is no CO2, if there is no CO2, I need new hands and new voices. If there is no CO2, what is the result? Let's see. New voices and new hands. Reem Safiuddin, yes. What do you think?
Yes.
If there is no
If there
CO2,
is no if there is no CO2, the lime will stay colorless and clear.
yes, very good. So lime water, it becomes or it stays clear. Very good. So the lime water stays clear.
Clear.
Very good. Very good. Thank you. So here I'm going to
Welcome.
move to other questions. So for this question, all of you please lower your hand and read the question very well. My question is, what do we call the instrument used to measure the oxymeter? So I need new hands and new voices. I want to hear new voices. Okay, Adam Hayek, why do we use the oxymeter? Yes, Adam Hayek,
I can't hear. Can you repeat, please?
why do we use the oxymeter?
To take the CO2 from the fish.
Oxymeter, why do we use it? Oxymeter. For what do we use the oxymeter?
Me.
It's used for what? To measure what? Yes, Adam. Here it is. What is the role of the oximeter? It's used to measure the amount of oxygen gas, right?
Yes, yes.
Okay, so the role of the oximeter is to measure the amount of oxygen gas. Mia Hassan, Thank you, Adam. Mia, good morning.
Good morning.
So if I ask you, Mia, what do or what does the fish inhale and what does the fish exhale? What does the fish absorb or what does the fish release? Yes.
Oxygen and releases CO2.
It. Can you repeat? I didn't hear you.
Yes, it inhales
Yes.
oxygen and
Yes.
exhales CO2.
And it releases CO2. Very good. Thank you, Mia. Moving for other. I want to hear new voices. Selena Bawab, good morning. Selena, good morning. Selena, can you hear me? Selena, good morning. You can speak right now. Okay, I think I have problem. Nora Rasas, good morning, Nora. Nora, good morning. You can speak right now. You are unmuted. Nora Rasas, good morning. Can you speak right now? I think you had a problem in their connection. I think. Carlo, good morning. Carlo got up. Carlo, good morning. Yes, Carlo. Good morning. Okay, let's say for Leia Deya. Good morning, Leia. Okay, Carlo's here. Carlo's here. The next question is for Leia. Carlo, what do we call the test used to detect the presence of carbon dioxide? What do we call this test? Yes, Carlo, what do we call this test? Carlo, do you hear me? So I think Carlo didn't hear us. So let's move to another one. Karam Atwi. Good morning, Karam. Yes, what do we call the test that is used to identify the presence of carbon dioxide? What do we call it?
استاذ هو بالليمون جوس مش هيك؟
No? It's called what?
هو بالليمون جوس.
No, sky lime water test. Okay?
اوكي.
Lime water test. What do we call the test?
هيدا هو بالليمون جوس.
Okay, but it's called lime water test, not called lemon juice test. Okay?
Okay.
Okay, so lime water test is done to identify the presence of carbon.
Of carbon dioxide.
So if it's turbid, so what does this mean? This means that we have carbon dioxide or not?
If it's what?
If it's turbid or milky.
We do have carbon dioxide.
While if it stays clear?
We do not have CO2.
Okay, thank you. Let's move now to new voices. I want to hear Dalala Saili. Good morning.
Good morning, Ustaz.
So what do you think about lime water test? Why do we use it, the lime water test?
Wait.
To test the presence of what? Which gas? Carbon
CO2.
CO2. Very good. Carbon dioxide. Thank you. So here we finish everything for our session for today.